Hello everyone, my name is Veer Kumar Patil and today we are diving into a powerful tool that's changing the containerization landscape, Podman. As containerized environments become the backbone of modern software delivery, we often hear Docker being the go-to choice. But today, I'm going to introduce you to Podman, a flexible and secure alternative that's gaining significant traction in enterprise environments. Let's explore why Podman is becoming essential in this space. Podman, which stands for Podmanager, is an open source container management tool for developing, managing, and running OCI containers. So this definition has two important keywords, OCI and containers. Let's try to understand these two terms. OCI, which stands for Open Container Initiative, is an open governance structure for the purpose of creating open industry standards around container formats and its runtime. The core goal of this project is to ensure standards for containers and future container platforms that preserve the flexible and open nature of containers. When I say flexible and open nature of containers, it should follow certain things and it should not follow certain things. For example, containers should not be bound to a specific client or orchestration stack. Containers should not be tightly associated with a particular or any vendor. Containers should be portable across wide variety of operating systems, hardware, and architecture. So OCI try to make sure that any containerization platform or containers engine should follow these particular things. Now we understood the OCI, let's try to understand the containers in detail. So before actually jumping onto this particular definition, let's try to understand container in layman's terms. Imagine you're moving into new house and you have all the belongings packed into into neatly labeled boxes. Each box contains items that belongs together. For example, kitchen supplies in one box, books in another, and clothes in another box. These boxes help you to keep things organized and easy to transport without worrying about them getting mixed up or damaged. In computing, container works similarly. It's lightweight, portable unit that packages up your software along with everything it needs to run, like code, libraries, and its dependencies. Whether whether you are running it in on your laptop, server, or cloud, it runs without any last-minute surprises. You might think, what containers try to solve? Container tries to solve a problem that every developer faces. It works on my machine, but not on yours. Let's try to understand with an example. Let's say you are working on a web application and you have set up it on your laptop. You have set up it on your laptop. You have installed all the dependencies like specific version of a Python, certain libraries, and even a database version, a particular database version. Everything works perfectly fine on your machine. You run the app and it behaves exactly as you want. Now, you share this particular project with your colleague who tries to run the same app on their machine, but suddenly it doesn't work. Maybe they are using a different version of a Python, some database configurations are different, or some libraries are missing. The app crashes or behaves unexpectedly, and your colleagues ends up frustrated because what worked perfectly fine on your machine just doesn't seem to work on theirs. This is the classic scenario where environment differences causes inconsistencies. Containers solve this by packaging your app and everything it needs, uh, its specific version, libraries, and settings into single unit. So no matter where you run the container on your machine or on your colleague's machine or on your production server, it works the same way everywhere. This consistency is why containers are so valuable for development and deployment. Now, what we have understood the containers, let's try to go back in time and try to understand virtualization versus containers. So I'll quickly jump on to the next slide. Okay. So imagine, just concentrate on the left-hand side image. Okay. Imagine you are having a data center filled with servers or a hypervisor running multiple applications. Traditionally, we used virtual machines to run these applications so as to have a isolated environment. For example, if you could see, we have a green color app 1, orange color for app 2, and red color for app 3. So you might think, what's the problem with this particular approach? Let's take an example. You wanted to scale the app 1. So in order to scale this app 1, what you have to do is you have to scale up the entire stack, the guest operating system, its required libraries, and the app itself. This particular operation is time consuming as well as, resource heavy operation because it consumes significant memory, CPU, and even the cost as well. This particular approach is simplified with the containerized application or with the introduction of the container engines. Okay, so if you could see the key difference between the virtualization or virtual machines versus the containers is the operating system, and on top of operating system we are having a container engine. So engine is responsible for managing your application, its dependencies, and its runtime. So whenever you wanted to scale up an application, you just need to scale up the application, its dependencies, and its runtime, and which is much quicker, much cheaper, and much resource heavy operation. Or in other terms, it is very lightweight thing to do. So based on this particular understanding, I try to devise some key differences between virtual machines versus containers or virtualization versus containerization. So let's deep dive into those, or let's try to understand those key differences. So I try to group those into different categories. Let's check one by one. The first is machine level functionality. So when it comes to virtualization and containerization, when this machine level functionality plays a key role. So for virtualization or virtual machine, hypervisor does that particular functionality. For example, KVM, Zane, VMware, or Hyper-V, these are the applications that will help you to do virtualization. But when it comes to containerization, container engines like Docker and Podman gives you a machine level functionality. Second is management. So whenever you wanted to manage a virtual machine, you have to rely on the virtual management interface. For example, if you wanted to create a VM, you're using VMware, you have to rely on VMware's user interface. Similarly, for hypervisor, you rely on hypervisor uh, for creating a virtual machine there. Uh, when it comes to container, we can use container engine itself or the orchestration software like Kubernetes or OpenShift. So we have an liberty over here. You're not relying on a particular application itself in order to manage the containers. Second thing is like the virtualization level. Okay, so whenever you wanted to virtualize a particular application along with its operating system, you completely, or fully virtualize its environment. So if you could relate to the image that I had shown, you have to, virtualize your operating system, the guest operating system, its the application dependencies and application itself. But when it comes to containers, we have to virtualize or, we are containerizing only relevant parts. Now, let's go to the next difference, size and portability. So when it comes to size, right, VM generally are in GBs and their portability relies with the same hypervisor. So just to give an example, if you create a VM with VMware as a hypervisor, then you cannot port it with other hypervisors like Hyper-V or KVM or Zen. But when it comes to containers generally in MBs, and they are portable with any OCI compliant engine. So let's say you had an image that is created using Docker engine, you can still use it with Podman, and it's vice versa. So after understanding, what is Podman, Podman basic introduction, then containers, OCI, and difference between virtualization and containers. Now let's try to understand the architecture of Podman. Again, before actually going into the architecture of Podman, let's try to understand the architecture of Docker itself. So Docker operates as a single daemon process that manages the container lifecycle, network, storage, and everything. Okay, so Docker basically work as a client server model where the Docker client or the Docker CLI interacts with the Docker daemon, which handles the requests like building an image, running a container, and managing the containers. Okay, so basically, Docker daemon is a key component, and it needs to be running as a background service in order to achieve the containerization with Docker. Okay, so so again, this is one of the thing that you need to understand before going into the uh, before going into the Podman architecture. Okay, now let's uh, try to understand what's the problem with this particular architecture. You know, so as Docker daemon is running in the background and it has to run uh, as a process, it should have a root privileges first thing, and it is running a Docker daemon is controlling every other containers or the container activities. If your Docker daemon uh, gets some issue, your all the containers are at stake. That means your all the containers will be again destroyed. For example, your Docker daemon itself get crashed, your all the containers will be also crashed. So it's a kind of a single point of failure when it comes to Docker. While when it comes to Podman, Podman, unlike Docker, Podman does not rely on a single daemon. Instead of it runs as a child process of the Podman CLI itself, meaning it forks itself, attaches it to a container, and becomes another process. And that way it becomes a rootless, and it provides enhanced security. So even though the Podman get crashed, it will impact only that particular container, not multiple containers. That is the case with the Docker daemon. Another concept that is very important for the Podman is, Podman introduces the concept of pods, where you can group different containers with sharing network, like storage, which is similar to the concept of pods. So that is another key component that helps to Podman become a unique from the uh, Docker. Okay, and as I talked about the security, right? So as the Podman itself is not running uh, in a root mode, it gives you a better security over the Docker, because because it has a smaller surface of attack as compared to Docker. Uh, so this is the thing that I wanted to cover. Let's quickly recap what we had covered in this particular video. So we understood what is Podman, understood what is OCI and containers, then then we understood why containers are needed, difference between virtual machines and containers, and lastly the Podman architecture. So that's it for this video, guys. Thank you. Thanks for watching. Stay tuned for more videos.